Alright, hello guys, welcome back to a long-awaited video. This one is going to be on our Ethernet project, guys. I know, it's been far too long since I've done one of these, but this is one of our embedded Ethernets. This is using our PicDem.net 2 kit. We will be using the Ethernet onboard capability. I believe the chip is an 18F... I can't remember the actual part number. It's 18F something J60. Let me look. Looks like it's a 18F 97 J60, which is a, I believe, a 32-bit microcontroller. That's what it is. This is the web page that we are looking at on it. I've got it connected to my own home local 192.168.1 network. It is given the IP address 140. I pulled it via DHCP. I think in some of the last videos in this series, I show you how to do a static IP address and things like that. But for right now, I'm just using good old DHCP. I reflashed it, reprogrammed it, so it's all back to square one. So if you were to just open up the box and run this, the only reason I know some of you might give me grief for doing a development kit, but really, honestly, it's the most bang for the buck if you're wanting to try this out instead of having to, because when you're dealing with TCP/IP and you're doing Ethernet, and if you really want that 100 Mbps and you really want to test things solidly, you really need it all put down on a board. And by the time you scribe your own board, which is kind of hit or miss because the chemistry, you can't really make sure that the copper is perfectly the same thickness and is perfectly etched properly and things like that. It's better to just have a board house make it. Well, by the time you have a board house make it and everything else, it gets a little pricey, and you just might as well go with a dev kit, just because they give you everything that you need. They give you buttons, LEDs, all kinds of different pieces of hardware. Plus, this PicDem.net 2 kit has both the chip, which I can't remember, it's one of the ENC 26J60s or 68J60 or something like that, which is one of the actual chips that you can go with any microcontroller. So basically it adds TCP/IP capability to any microcontroller. I think it works over either SPI or I2C, I can't remember which protocol it is, but it basically has that on board as well. So you get to play with both different kinds, see how each one is coded and how each one differs, whether it be on board or be one of the on-a-chip modules that's off to the side. You can play with both for the PicDem.net 2 kit. So anyway, guys, let me get a drink, refresh my voice. Oh, that's nice. And we'll get started here. Now, those of you that have ever checked out one of these, or at least seen some of my last videos, you get this pretty cool little demo page that kind of flips through all the different things. You can send email, you can do DNS, you can do authentication, cookies, file uploads, you can do all that stuff with this thing. One of the main things that everybody wants to know how to do is obviously how to mess with the GPIO over the internet. So that's what this little demo does. There's actually, all these LEDs are actually on the board itself, and as I click these, it is turning the LED lights on the board as I do it. Same with if I push one of the buttons. We'll push that button. As you can see, the button moves. It changes direction, as you can see. And then even if I change the potentiometer, you see the value change right here. So anyway, so that goes to show you that's the main GPIO and analog to digital conversion and thing that you can do with this thing. Well, let's see, how can we actually create our own web pages and actually use this stuff, not with the pre-built things that are out there. And it proves to be a little bit more difficult than you first imagine, like when you read through it. At least I know it was for me. That's why this video took so long, was because I had to spend quite a considerable amount of time figuring out how exactly this all goes together and how it all works. But good for you, you guys just had to wait for the video. You don't have to go through that painful struggle, which is why I'm here and why I love making these videos for you guys. I like to simplify things. So I'm going to show you right here, right now, how to actually get this thing to work and build your own custom web page. We're going to start off slow, and we're going to just do dynamic variables for this one, hence the title of the video. So we'll do dynamic variables, which means basically if you have a variable in code and you want to spit out the information that's in that variable to the screen, you can do that quite easily, and I'm going to show you how. So first off, excuse me, you're going to need to launch your MPLabs X and bring up the mplab.x folder, which is the actual demo app, and I'll show you where that's located here in a second. But that's what I have up here in my MPLabs X. I'm going to be doing this in Linux. Windows has similar path structures, so bear with me as I'm doing this. I'm doing this all in Linux just because I love developing in Linux. It's very easy to develop things in Linux, and so I like using it. So forgive me, Windows people, but the directory structure is pretty much exactly the same. So what I've done is, as in our previous videos, I have downloaded the, let me see if I can find it, the microchip libraries. Let's make this bigger so we can actually see this. Come on, mouse cursor, work for me. So let's see, let me do another LL. So this will actually, there we go. So what I have downloaded is the 6.15.2013 version of the TCP/IP stack. And so when I extracted it, it basically built, let's see, this folder right here. And that's the folder that all this stuff is going to be in. So I'm going to go ahead and CD to that. So I'm going to change directories to the Microchip Solutions v2013 6.15 folder. Okay, inside here you will find, I'll run a clear so you can see it. Inside you'll find these different folders. Now you're going to have to keep track of the microchip and the TCP/IP. They are different. One has the utility that you need to be able to upload your custom web pages to your device. So in the case of the picdem.net kit, you have a couple of options. It has an onboard separate EEPROM chip that's on it that you can upload basically a binary version of your web page folder. And yes, I do say folder. You can create multiple web pages, multiple HTML files, and make sure that they are HTML files, not HTML. I made that mistake myself. But make sure they're HTML files, and you can have, you know, different folder structures even with different sets of files in it, to where you may navigate to have different links in your web pages to go to other web pages and things like that. That's all great and good as long as you keep it in the same folder. Just like when doing web development, you have a root folder that you keep all of your web page stuff in. As long as that's all together and everything, you're good to go. And we'll see that here in a second. So to get to that utility, because you need to be able to install your web pages to your device, we're going to navigate to the microchip directory, to the TCP/IP stack directory, then to the utilities directory. Okay, now if we do an LL in here, what you're looking for, this is a Java applet program. So even in Windows, I think I may even have the Windows one, I downloaded them both. In the Windows environment, same path, okay? So same path, it's going to be whatever your extract folder is, and then microchip, TCP/IP stack, and utilities. There is a .jar file, which those of you, I don't know, those of you that know Java will know what this is. Those that don't, that is actually a Java executable. And you're looking for the MPFS2 jar file, which it will be the Java executable file that you need. I can't remember what MPFS stands for. I think it's Microsoft something file system. I can't remember what the P is. But basically, it's basically kind of like a compression tool. It compresses it all into one file that you then can upload to your device. So we need to run this. So what I'm going to do is I'm going to give it a /MPFS2.jar, but I'm going to give it an ampersand because I want to run this in the background so I get my terminal back. So once I run that, and taking a minute to come up. Here it is. So it's our MPFS generator. So I'm going to put that down here just so I can have this back. What this will do, like I said, is this will generate the image of your website so that you can upload it. And what's great is it also uploads it to your device as well, as long as you have it configured and you have an IP address assigned to it, and you can actually ping it and reach it. You can use this tool to actually upload to it. How this works is, like, let's say right now I'm going to create my own website. So let's go back to our terminal. What I'm going to do is I'm going to back up a few directories back to our main extract directory. I'm going to cd to the TCP/IP directory. Then I'm going to go to the demo app, and inside here, excuse me, there's a directory called webpages 2. Okay, inside this webpages 2 directory is where the default web page is. So I'll just show you that real quick. LL. Okay, inside here, see, there's the index. Okay, and if we're to VI that, or vim it, you'll see that here's the stuff for the connection to demo. That's for the different demo board is lost. If we go down here, here's this site demonstrates the power and flexibility of scalability of blah, 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 blah. Okay, this is the HTML file for this. See, this site demonstrates power, flexibility, blah, blah, blah. So that is the actual HTML for that file. So this is that default website, and all of its subfolders, all of its JavaScript files, all of its CSS for its formatting and text formatting and everything, as well as the status XML file. Now this is an important file, okay? Let me go ahead and VI that one. The status XML file. This is the transfer file between the code of the microcontroller and the web page. So this is the key. So you want to pay attention to this one. Anytime that you want to transfer data from the web page to the actual microcontroller of the device. So if you want to transfer the status of a button, the status of an LED, the digital representation of the ADC, if you want to transfer the value of a variable or something like that to the web page, this is the conduit for how it's done. You basically define in here, using encased in tildes, you define the word that you're going to use. And yes, you can use parentheses and give it like an index value. That's what these LEDs are for, and the buttons. And what you do is you can define this, and in the code, which I'll show you in a minute, there's a deal that generates the code that will correspond to this, to where the TCP/IP stack will handle these different things, and whatever, like the value of LED 0, it will send that value, whether it's a 1 or a 0, to the HTML code. And you can call these, and we'll see that later on in other videos. You can call this, well actually you'll see it in this video, you can call this LED 0 or whatever that you put in here in the web page and get it to display whatever value it is. Now, in the sense for this original web page, they're taking the value of 0 and 1 and they're making it either a gray dot or, what is this, like a green color? I don't know, green or red, I don't know. I'm colorblind, so anyway. But they're basically giving it a color. Okay, based on whether it's a 0 or a 1, and where it gets its information is from this status XML page. So you'll see as we go along in the C code of our firmware for our microcontroller, it actually references and edits and modifies the status XML file. And then the web page also pulls its data from this XML file. So this is the key for all of it. So we'll be looking at that. So what I'm going to do is, let's make our own web page. So I went ahead and created my own folder called My Web Page. Okay. Inside, I created an index and the status XML, because remember, the status XML is very important. These are the two basic things that you need to bring what is in the microcontroller to the web page. Okay, and vice versa. You can take data from the web page and bring it to the microcontroller, basically bring it to the firmware. So this is your interface between the application or the user and the firmware. Okay, is that status XML. What I have done is in our index, I've created a very, very simple HTML code where I just gave ourselves a paragraph or whatever and said, hello everyone, did a couple of line breaks. Then what I did was I created a class, I'm calling it example box, and I said build date. I want to be able to display the build date. Okay, so I name it build date. Okay, encase it in tildes, which tells the firmware that it's a dynamic variable. Okay, as well as I created my own custom variable. This build date is actually a variable that's already in the code. I'll show you where that's at here in a minute. That's already in the code that it can use. It automatically builds the build date and is a variable that you can use. I went ahead and created my own custom variable that we can do whatever we want with. So anyway, and then of course I closed up the body and the HTML code with it. Okay, so that's my index that I'm going to use. Now, here's where we tie it all together. Is I created a status XML. This is how you create this. It's just response with a slash response, okay? And inside, whatever you name your variable is going to be the name that's inside the greater than, less than symbols, okay? So build date, and then in the tildes and build date, and then the backslash build date. And the same thing for my custom. My custom encased in tildes, and then backslash my custom. That's it. That's all you need. Now, how does this all tie together? That's probably what you're wanting to know. Well, here is the greatest and coolest thing. Is that tool that we had, let me get it back, this MPFS generator, it does all the heavy lifting for you, okay? So now I'm going to say start with web page directory. You can do a pre-built MPFS image, but I'm going to do a web page directory because that's what I created. I created my web page directory, so that's what we're going to do. We're going to do, it'll do the whole directory. Anything in the directory, it'll do up. So what we're going to do is we're going to browse, and I'm going to back up a level. I'm going to get my web page because that's the one that I want. Okay. Now, here's where you have a lot of options. Depending on your hardware and how you've set it up, you have multiple options. You have a binary image file. You have the PIC18, PIC32 image file. You've got a PIC24 DSPIC image file and MDD. I hate to tell you this, guys, but I don't remember what MDD stands for and what it does right this second. But I do know what these two are, and really, it's these three would be the things that I would probably be using if I were going to be building something. The binary image file, what that is for is if you have an external EEPROM, which in the case of the PICDEM.NET 2 development board, it has an external EEPROM that's built for storing the image files for your HTML code. Okay, so that's probably the one that I'm going to choose. However, if you were trying to save space, and if you're a one-page, you just have one index page that has everything on it that you want, and you need nothing more, which probably will be the case for most people since they're wanting to just be able to access the GPIO and maybe turn lights on and off and things like that. Maybe they want one web page or something like that. You can store it on the internal EEPROM flash that is inherent to the microcontroller that you're using. In order to do that, you will need C code that will actually access that internal EEPROM and record it to it. So that is what these two options are for, depending on what kind of a microcontroller you're using, whether it's one of the 18 or 32s, or if it's a PIC24 or a DSP or a DSPIC. It will generate, what this will do will generate the C code that can be included in your project and then burned as firmware to your microcontroller, and then all of it gets put at once is the way it works, instead of having the separate EEPROM where you can upload it. Now, the give and take, why would you want to do one over the other? Well, with the C code generator, or basically using the PIC image options, you would have to recompile the code every time you wanted to make a change to your web page. Essentially, you'll have to recompile the code and re-upload the code via an ICD3 or a PickKit 3 or PickKit 2 or whatever it is, you would have to basically re-upload the code to it and rebuild the firmware. Certain situations, maybe that's fine. Some situations, especially like in a production environment, that may not be the best thing because web pages change all the time. The binary image one is nice because you can update your web page as long as you're not changing the dynamic variables, and you'll see why here in a minute. As long as you're not changing dynamic variables, if you're literally just changing a picture on the page or changing the text or changing the font or the size or something like that, then you just need to re-upload the web page to the board or to the product or whatever you're working with. You just need to re-upload the image. Well, the binary image would be the best way to do it because all you're doing is just reprogramming the external EEPROM chip that's on it. You're not actually having to rebuild the whole software for the microcontroller. So that might be a better way to go. So depending on your application, you may want to choose one of these options. Like I said, the MDD, I can't remember what that actually stands for, but it is in the software documentation. So now we have the project directory. We want to say, where do we want to store our .bin image, which I just went ahead and left it as the demo app directory. You could specify a different one. You could specify the same one. It depends wherever you want it. But the key is, what nothing tells you is it will generate a header file that you need to include in your code. What I mean by that is, since we created our own status.xml file and it has different variables than was created in the other one, for instance, if I back up and I go to web pages 2, and we go to the status, and remember there's LED 0, 1, 2, 3, 4, 5, 6, all this stuff. And then for mine, I only have 2. What this does is it actually has to generate C code for these dynamic variables or dynamic buttons or ADC points or anything that is dynamic. It actually has to generate C code, and there is what's called a handler that will actually stuff the information in that variable and get it stuffed into the and update the status.xml file with the contents that it needs for it. So you need to rebuild code if you add or subtract dynamic variables or switches or LEDs or anything like that. If you're going to do anything to the status.xml file, you have to rebuild your code because it will regenerate a certain header file. And I'll show you that in a minute. Well, actually, I'll show you it right now. The header file that it generates is the http print.h header file. What this has in it is, if you look, there's a callback, and it says case of 1, then it's the print hello message, print cookie name, print build date, and it goes hand in hand with the custom HTTP app, because the custom HTTP app.c, which is the source file, has defined the HTTP print button function, as well as the print LED and print, LED section and all these different print commands. It all gets rebuilt with this guy. As you can see, HTTP print, and then whatever you put in as the D word, see, gets called. And so it will call HTTP print hello message or file or cookie name or whatever. All of these, if you notice, there's LED, there's LCD text. All this stuff is basically defined in the status.xml. So watch what happens when I rebuild, when I click generate. This will all change around. This code will completely change around to the dynamic variables that I have created, which in my case there's only 2. So watch this. I'll click generate and upload. I have my device connected, and here it is telling you that remember to compile your MP Lab project, because all that stuff has changed. It has regenerated that http print.h file. So okay. So I'm going to click OK here. Okay. Oh wait, I got to click this one first. It's telling me the image was uploaded successfully, so it could contact it. I had the right IP address and whatnot. And if you need to change this IP address, you can just click settings here and change it. I'll show you. You can just hit settings and then change it around. But the username and password, these are the defaults. You can change it in the C code, but I'm not going to go into that. And I'm using HTTP because I'm just uploading it through port 80. If you use FTP, then it'll actually use the file transfer protocol, and it'll actually upload it through port. What is FTP? Is that 22 or is that SSL? I don't remember. Anyway, the FTP port is what it's going to use and whatnot. But I just used HTTP. Totally fine. So I generated that. That's generated and uploaded. Now, if I go in here and look at this, it basically updates. And look, now I only have two. I've got a build date and a my custom. Okay, because the my custom, remember, is the one that I made. So now, if we remember back, let me pull up our terminal again. If we remember back to my index, okay, I'm saying hello everyone, and I'm going to display the contents of build date, and I'm going to display my custom. Okay, so let's see if we got this configured. Now, what I have to do is, now that this code has changed, because I changed up the dynamic variables. Like I said, if you're changing font or colors or things like that, pictures on your web page, this does not have to be rebuilt. Okay? It's only when you change dynamic variables or LEDs or anything touching the firmware, where you need to transfer information from the firmware to the web page, then you will have to actually rebuild your firmware code, because there will be different address pointers, or what they are calling callback IDs. There will be different callback IDs associated with the different dynamic variables that you're using. Okay, so I'm going to go ahead and hit program. Okay, and what this will do is, down here, if we look, it's going to take and rebuild all of the code, which I'm getting these little error messages just because I think they built this for Windows and then ported it to Linux, so there's lots of spaces and things, and it's telling you, hey, spaces are dangerous on Linux, right? You know, those of us that are Linux programmers, we know that Linux does not like space. It does not like spaces. It likes underscores and dashes and things like that, but it does not like spaces. So it's basically warning you of that, which everything is fine, everything is built properly, so you can ignore these messages. They're all right. It's just, like I said, I think they built it on a Windows machine and then ported it to Linux. So now it built successfully, so it's skipping right along and going to my ICD3, which is what I use for my programmer, and it is now programming the microcontroller. So give it a few seconds. Okay, it is now done programming. So now that that's been rebuilt, we've programmed it with the new stuff, we've uploaded the new software, it completed or the new web page, and it is completed properly. So now all there is to do, guys, is check it out. So I'm just going to hit the refresh button, and we should see our web page. And there we go. All right. It displayed the date, and then it displayed, this is my custom. And that's what I had assigned to that my custom variable. Now, you're probably wondering, where do you assign this at? How do you fill that variable? Well, I'm going to show you. If we go back to our MPLabs X, we go back to our code. If it will let me go back to our code. Okay, I'm going to go to this custom HTTP app. Remember, HTTP print and custom HTTP app work hand in hand together, and I'll show you why. If we scroll up here, I have created, and I went ahead and did this myself, I created a HTTP print my custom function, basically. Did a void, and I have the TCP put ROM string, and it's, you pass it the SKT HTTP, and you have to typecast it as ROM void, okay, and as a pointer. So that's what this is. This is a typecasting. And then I just put in my text. See, just like it was up here, they typecasted and put in the text for the date. I just put in my own text. This is my custom. And then voila, we get, this is my custom. All right? So that's basically how you go ahead and create your own custom web page and use dynamic variables. I'm probably gonna, this video probably went on for quite a while. It looks like it's been a while. So I think what I'm gonna do is I'll probably stop here, and we'll leave that off with dynamic variables, and we'll continue with the next video in adding switches and doing some JavaScripting, because the switches, they need some JavaScript going on, because you can actually click them and mess with them, so far as like the LEDs. The LEDs, you can click them and it changes states and things like that. So you need some feedback. You need to get the keyboard and mouse feedback from the user and translate that into the status.xml file. You need to update the status in those different points that you have, so that way it can be fed back to the microcontroller and it'll update the actual GPIO on the physical device. So for now, this is how you take a variable that you have in your software and display it out to your web page, is using dynamic variables. This is all also defined in if you go to Microchip's website and where you download the TCP/IP stack, there's a help file section. If you download that, there's a help file that is for the TCP/IP stack, and you can open that up and it is all defined in there. So anyway, guys, basically as a quick rundown, all you need to do is you need to launch your MPFS generator, okay? Create your website index, as well as create your status.xml file. Put whatever dynamic variables you want to use, put them in your status.xml file. Then in your MPLabs X, if they are new variables other than these that are in this custom HTTP app source file, you will need to go ahead and create functions for them, because it will try to call those functions. So you'll need to create functions for the new variables that you've added to your status.xml file. Okay. Once you've done that, then you need to go ahead and choose wherever your web page is stored. Use the web directory. Choose whichever form of image you want to use, whether it be generating C code or generating the binary image. I did the binary image. I could maybe try doing some C code. I haven't ever done it, and then post a video showing you guys how to do that. But for right now, I did the binary image. Select your project directory, name it. Go ahead and set up your whatever your IP address is that's on your device right now, as long as you can ping it. Click generate upload, and what it will do is it will upload the binary image, as well as generate a new HTTP print.h file, because you've made changes to your status.xml file. Once that gets generated, since you did make changes to it, you will have to then reprogram your microcontroller with the newly created header files and C source code that go hand in hand with each other for your callbacks. And you are ready to go. You are off and running. And honestly, it sounds like a lot, but if you sit down and play with it, it actually is very simple. It actually does all the hard work for you. It builds all the callbacks, builds all the prototypes for your functions. It even generates your header file for you. It compresses all the HTML files, puts them into the EEPROM. It does all the hard work for you. So it actually is quite simple. There's just some steps to it. So guys, hopefully you've enjoyed this. Hopefully it hasn't taken too long for y'all, and I hope you got a better understanding of this. I know I sure have with taking this on. My voice is about done. Guys, take care, keep coding, keep building. Got some exciting stuff for you. Like, subscribe, share, all that jazz. Check me out on Twitter. I love to post comments, updates, anything about when videos are late or anything like that. So check me out on Twitter. Check me out on Instructables. I'll be posting some new stuff. I got a Halloween video that we'll be creating. I'll post here, as well as we'll post it on Instructables. If you haven't friended me yet on Google+, I am google.com/+misperry. Check me out there. My Twitter is misperryee. Go ahead and add me there if you're on Twitter. That way you don't miss out on any updates or anything, especially the squirrely funny stuff that I'll see out in the world that I love taking pictures of and showing you guys, because some of it is actually pretty amusing. So take care, keep coding, keep building, guys, and we'll catch you next time. And that ought to do it. See you later, guys.